Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is this MCQ is in front of you. This MCQ is about Silane. So I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry, after some time we'll get the right answer with mechanism. I believe you have tried by yourself, so it's my turn to give you the right answer. So you can see the question that this is actually a reagent, or you can consider this is 1,2-diol, and this carbon attached to this SiMe3 group, and finally the condition is potassium hydride and diethyl ether. And we know that potassium hydride only act as base. Okay, and in this case, what are the acidic centers there? Only these two hydroxyls. Okay, so acid base are there, and we know acid base reactions are the fastest. So how the reaction happens? First, this hydride means potassium hydride actually is ionic compound, so its hydride minus will abstract this proton. Okay, this proton. Why? Because these alkoxide, in this case you can say the counter anion is potassium, has some fate. And by the way, this hydride plus this proton, because this proton is delta plus in charge, they react and it will produce this hydrogen gas. It will come out. So this alkoxide in the next step, what they will do? It will do. By the way, you can see that, sir, in this case it is in anti. Here you are writing cis type. Why this is? Actually, remember student, this is actually a CC bond, sp3 CC bond, single bond. So CC rotation is possible. First point number one. Second, it has a fate, because in the next step, what expected that this can attack here and it can come here. So ultimately it will produce this silyl ether type derivative and carbon ion. This is the carbon ion or negative charge on carbon atom. Now a question may come in your mind that, sir, from oxygen anion O minus you are preparing a carbon ion C minus. Is it stable? Because we know that carbon is relatively means less electronegative compared to oxygen. Actually, it's true that it's not that much stable compared to the first one, but it has some additional stability. Why? Because of this silicon oxygen bond formation. So what is the uniqueness of this silicon oxygen bond? So this silicon oxygen, from apparently you can see, okay, this is a simple sigma bond, single bond. So it's true, obviously it's a sigma bond, but it has an additional stability, means the lone pair of oxygen in the p orbital can overlap with energetically accessible vacant d orbital of silicon. I repeat, energetically accessible vacant d orbital of silicon. So electron donation from oxygen side to silicon side possible. It means the single bond between this silicon oxygen is not a purely single bond. You can consider this is as a partial double bond character. So if it is a partial double bond, so it means it's a stronger bond, and that is the, you may consider that is type driving force. Now in the next step, what can happen? This is actually a carbon ion type derivative, so it can push this pair of electron and it can leave. And ultimately what it will produce? It will produce, this part is alkene, and previously there was a silyl trimethyl silyl ether derivative. So in short, what is obtained? This part is called silyl enol ether. Okay, and sometime this is called also enolate. By the way, I have already discussed dedicated lectures on silyl enol ethers and enolate. So these enolates are nucleophilic. Why? Because you can see there is a lone pair on oxygen atom, so it can push here and this can come. Consequently, what it will end up? It will produce this side R. I am not focusing. So this carbon ion minus, this is a carbon ion minus C, and this is a O double bond SiMe3. Fine. And here this oxygen have a positive charge on itself. And because of this negative charge, this is nucleophilic. Actually, if I say, it is weakly nucleophilic, because This nucleophilicity you can see because of charge separation, and we know charge separation is associated with some destabilization. So contribution of this canonical form into the overall electronic distribution of that molecule is relatively less. So that's why it's mild nucleophilic. So what is the answer of this question? The answer of this question is option C, this one. Now if this question is asked in your exam less than 30 seconds, how can you solve? First of all, you need to understand that potassium hydroxide is actually a particularly base. It is not nucleophile. So it can only react in between these two hydroxyl. Now second option, which will attack? Attack will happen where the O- have some fate. For example, if it attacks, it can attack the silyl center and it can form silyl enol ether derivative. So this part if you understand, then option A and option B gone. Okay, and another thing student, this hydride mediated condition, carbon silicon bond can't be break. Fine, because it could be broken using like means those fluoride type thing. So that's a difficult thing. Breaking silicon carbon bond is difficult thing. Now first two option gone, second left is you can see option D and C. And by the way, if these water molecules are eliminated, ultimately means from this one water molecule eliminated, what it will result? It will result an alkene. So obviously this one is the answer, because water eliminated but still saturation. How possible? This is actually a potassium hydride base, so this hydride cannot attach to the double bond, not possible. So this is the answer. Now for that purpose student, few things needed. First, basic knowledge, understanding, practice and cool mind in the exam hall. Now in conclusion, what you have learned today, that potassium hydride is a good base but it's a poor nucleophile, because you know that sodium borohydride or lithium aluminum hydride, they are better nucleophilic because the hydride is in the sp3 type orbital, whereas in case of potassium hydride, this S2 means 2 electron on the s orbital, so that's why it is not that much good nucleophilic. Reaction of potassium hydride with alcohol results in alkoxide formation, alkoxide and hydrogen formation, and being a gas, this hydrogen comes out from the reaction medium and shifts the equilibrium rights in the forward direction. And this alkoxide can also act as nucleophile to the silicon center, because silicon oxygen bond is significantly stronger due to p-pi d-pi back bonding, and this back bonding electron coming from oxygen side. Now the OH or hydroxyl minus is not a good leaving group generally, but in alkaline medium it can eliminate and produce the alkene. And the final most important one, that silyl enol ethers are moderately good nucleophile. And by the way, there is a name reaction, Mukayama aldol reaction, where you can see the silyl enol ether acts as a nucleophile, and to activate the electrophile or carbonyl part, strong Lewis acid like titanium 4+ needed. Okay, so this is the overall discussion. I believe this video may be useful. Please write your opinion in the comment box, and thanks for watching this video. And if possible, please visit my another channel where I upload global warming and climate change related videos.